Let us meet in our fourth examination type question, in which we are going to look on the electrolysis of brine. So in this question, normally we see this question on question number 11, right? The question says, industrially, chlorine gas is produced by the electrolysis of brine. In addition to chlorine gas, hydrogen gas and sodium hydroxide are also produced. So this one is the diagram for the industrial preparation of chlorine. But as you can see, we are also producing hydrogen gas and we are also producing sodium hydroxide. Right? And remember, this one is an electrolytic cell, which means to say that the positive electrode there is our anode and the negative electrode itself is our cathode. Right? So now the first question says, write down the equation for the half reaction that takes place at the cathode. This side is the cathode. As you can see, the water is entering in, which means to say that our water is our reactant, and then we are going to produce some hydroxyl ions. So, and we are also having the production of hydrogen. So, which means to say that we are going to have the reduction of our water into the hydroxyl ions as well as the hydrogen ions from what we have there, because this one it's a cathodic reaction. So what we are having there in question 11.1 is that we are having a reduction reaction which is taking place. So our water which is in the liquid form plus 2 electrons producing 2 hydroxyl ions in aqueous form plus our hydrogen gas. So this one is our reaction which we have, and this one is a reduction reaction which is taking place at our cathode, which is the negative electrode in our electrolytic cell. Then the second question says, write the balanced overall net cell reaction omitting spectator ions for this cell reaction. So here we are told that we are supposed to write a balanced net reaction, and we are supposed to omit spectator ions. Now there is need for you to understand what are spectator ions. Spectator ions are ions that exist as reactants and products in a chemical equation. They simply watch the other ions reacting, like maybe you are just a spectator outside a football pitch, while these people the players will be playing inside the playground. So that is the same thing with our spectator ions. They will be watching the reaction taking place, right? So now we want to write the balanced chemical reaction. Already we have produced our reduction reaction, so there is need for us to actually produce our oxidation reaction. As you can see here, we are saying that we are actually having our brine. Remember, in our brine we are having aqueous sodium chloride, right? So we are having the sodium ions as well as the chloride ions. So we are going to have the electrolysis of our sodium ions into chloride ions. So now the chloride ions which are being produced are now going to, which are being produced when we are going to actually dissolve our sodium chloride in water. We are going to actually form an oxidation reaction. So we are going to have our sodium chloride aqueous ions. They are actually going to lose 2 electrons, and we are going to form chlorine gas. So this one in itself is an oxidation reaction, right? So this one is an oxidation reaction, and it occurs at the anode, right? So if we combine our first equation there, which is our reduction reaction and our oxidation reaction, we are going to form our overall net reaction, which we call a redox reaction. So the electrons which are being lost in an oxidation reaction are the ones which are being gained in our reduction reaction. So the electrons are going to cancel, and then we're going to form our overall reaction. So our water in liquid form plus the chloride ions in aqueous form will give us the hydroxyl ions, right, in aqueous form, right, plus hydrogen gas plus our chlorine gas will be our overall reaction, right? Then the next question says, state 2 functions of the membrane in the above cell. Here we're having our membrane there, right? As we can see, it separates the 2 electrodes. So the first function, we understand that it prevents the mixing of the products. It prevents the mixing of the products which we are producing here, right? So that's why we have that particular membrane, right? And then secondly, it allows the migration of positive ions from the anode to the cathode. Remember, we are having our sodium ions here. It will allow the sodium ions to pass through there so that they will combine with the hydroxyl ions which are right there, the cathode, and they are going to combine and form sodium hydroxide, right? So those are the 2 functions of our membrane. Use the relative strength of oxidizing agents present in a brine solution to explain why sodium metal is not one of the products in this particular process, right? So if we are going to actually look closely in our chemical reaction on question 11.4, we are comparing the reduction reactions for sodium and water. So first of all, we have our first reaction there. So our water liquid form plus 2 electrons, this one will produce our 2 hydroxyl ions in aqueous form plus our hydrogen gas. This one is a reduction reaction, and the electrode potential for this cell is minus 2, this one is minus 0.8. So this one is minus 0.83. That is from our standard reduction potentials, right? And then if we are going to take that one for sodium ion plus an electron, it will give us our sodium atom. This one in itself is minus 2.71 volts. So if we are going to look closely in our electrode potentials, we see that one for sodium ion into sodium solid, the electrode potential itself is more negative than that one of water. As a result, it will be very difficult for our sodium ion to participate in a reduction reaction readily than water, right? That's why we are saying that if our water is participating in our reduction reaction, then now it is a stronger oxidizing agent than the sodium ion. So our sodium ion itself is a stronger reducing agent than water, and will not be reduced, so it will be oxidized, so it will favor the backward reaction, right? So on question 11.5, we see to that chlorine is used in many useful products such as plastics, drugs, and disinfectants. Environmentalists are protesting against the large-scale production of chlorine. They base their argument on the negative impact of chlorine on humans. Name one negative impact of chlorine on humans, right? So you can choose in any one of the answers which we have, right? The first answer which we have is that chlorine itself is poisonous. It causes some health problems, like it affects the immune system. It can also affect our blood, and it can also affect the heart. And also it can also affect our breathing system. So there are breathing complications which are also linked to our chlorine gas. Why? Because it causes water retention in the lungs. So that's why we're having some breathing complications with chlorine. Again, secondly, our chlorine gas is used to make drugs that can be dangerous when overdosing. So if we're having the overdosing of these particular drugs, then definitely they can be poisonous. Then chlorine is used as a nerve gas, and then that nerve gas itself, it attacks the body's nervous system. So these are our answers for our question number 11, right? So stay tuned on the fifth question of our examination type questions.